Hi viewers, what I have here is just a very simple, very easily set up situation bench scale to illustrate the value of so-called redox additives to electrolytes, aqueous electrolytes, and in my case intended for inclusion in test supercapacitors. Now, of course, at 1.23 volts or so, we would expect with a decent electrolyte in water, oxygen, hydrogen gases, water electrolysis. Let's say 1.23 volts. It could be very slightly higher due to overpotential. Now, what you want to do when you're electrolyzing water is to lower the overpotential, a kinetic phenomenon. And in the case of supercaps, you want to increase the overpotential because you don't want water electrolysis occurring. You simply, to make a long story short, want to separate the positive and negative charges by a physical phenomenon well understood. So what I have in this beaker, it was colorless to begin, freshly prepared Epsom salt, magnesium sulfate heptahydrate. It's a 3 molar solution. I prepared 200 milliliters. And in there is 2.4 grams of potassium iodide. Now, potassium iodide is known as a redox additive. And that was placed in the solution. It was colorless to begin with, and then when I started my experiment, we got some coloration, and due to the presence of the iodide. Now, when I boost, here's my DC power supply, and I'm at constant voltage. I'm at 1.5 volts, no current. Now, you might say, well, wait a minute. When I look at this, I'm seeing gas there. Okay. At the negative lead, I have a section of graph oil. And at the positive lead, I have a section of graphite felt. Both are conductive. Now, when I boost this up, and that's why gases you can see there from higher voltages. Now, let me take you up to 1.7, let's go to 1.8 volts. 40 milliamps. Do you see the gas evolution? I'm holding my cell phone with one hand. Obviously, you can see the formation of gases. Let's take a look over here on this side. And gas evolution is occurring. Now, in supercaps, we don't want this to happen. We don't want the oxygen, hydrogen gases forming. So some people use ionic liquids. Some use deep eutectic solvents. Some are, and then you have to add a little bit of this and a little bit of that, like an organic carbonate or DMF. And some people are looking at so-called water and salt electrolytes. The acronym is WISE. And you have to read the fine print, because if any impurities get into the WISE materials, you're going to have problems. So it seems to me the easiest thing is to stick with a water-based, for many applications, water-based electrolyte solution. Okay, so we're drawing about 30 milliamps gas evolution. Now let me go back down. And I've seen gas evolution even at 1.6. Let me go to 1.5. no current draw. So if you see any gases coming off of there, it's simply from the surface, from the higher voltage. And in the write-up, I'll put more information on this. If you have not done this type of work, at ResearchGate, I uploaded a small outline of the importance of redox additives in aqueous-based electrolytes for test supercapacitors. It'll take a little while to settle down. That's the gas that adhering to the electrode. And of course, hydrogen gas is forming at the cathode, and reduction to a half reaction, reduction of hydrogen gas. Now, I work with water electrolysis, but these days mostly supercap work. So it is humorous. Here I'm trying to boost the potential so we don't get water electrolysis. Now, I also have sodium bisulfate, and this is at, I think it's 2.43 molar. And I have sodium iodide in that. I didn't test this one yet, but this is going to be very acidic, sodium bisulfate. That's okay. But you got to be careful with their redox additives. Got to make sure that you can use something compatible with the pH of an electrolyte you're using. So anyway, hopefully this would be a very good demo for home researchers and for professors working with undergrads, introducing them to energy storage, supercapacitors. We worry about electrodes. Most of my time is spent on creating composite electrodes, usually, but not always, with graphite felt. And for my purposes, if I can get 1.5, even 1.7 volts, for my purposes, that's fine, because I want to simply test out novel electrode composites, and I'm also modifying the separators, and I use glass fiber separators. Most people in the lab know it as filter paper. Now, it's the same as fiberglass, but when we're talking about filtrations, they call it glass fiber, and I want to use silinating agents to modify supercaps, but that's another story. One of my students, an undergrad graduating in December, will be presenting a paper on some of our work at the National ACS meeting in Washington, D.C., and that's going to be later this month. Okay, so still zero current, 1.5 volts. Now, of course, I got to do a little bit more modification here. There's a lot of research involved with this, and I want to test out hydroquinone redox additives and some others. But as I said, at ResearchGate, if you check for me, David S. Soriano, you will, I'm emeritus now, but still doing research. If you go to ResearchGate, you can find that paper on redox additives. Thank you very much for watching. We'll keep you posted as always. Bye for now.